This is part 2 of chapter 6.2 lecture. This section we're going to compute probabilities of binomial experiments. And so we said probability distributions can be represented with a table, a graph, or a formula. And so in this case we said binomial situations are going to be represented with a formula. Here is the formula. I'll have you write it down. Oops, that's going to be an X. Probability of P of X, 1 minus P n minus X. And so that's the formula here. Now you need to know some information. We're not going to do this by hand. Here's your instructions for StatCrunch on the side. What we do need to know is what the variables mean though. N is the number of trials. X is the value of the variable, the random variable. And that value is the number of successes. P is the probability of success. And it's important to note that the probability of success does not need to be something positive. It just means it's the outcome we're looking for. 1 minus P is the probability of failure. And in some books and notes, sometimes what you're going to see that this value is this variable is sometimes considered Q. We call that Q, the probability of failure. And so to answer questions, once we identify these values, we can go ahead and then calculate the probability of that event occurring. So this is very different than what we had to do in chapter 5 and how to use formulas and these equations and start to determine, or here we're just going to use this formula, but the StatCrunch is what we're going to plug it into. It's called a binomial calculator. Let's look at an example. Just make a note here also of some important terminology, at least more than what symbols go along with that language. So I put that there so you have that. So let's go ahead and calculate these probabilities. Yeah, I think I'll squeeze it on the bottom here. So the first thing we want to do, according to CTIA, 25% of all U.S. households are wireless only households, no landline. They only have cell phones. What is the probability of obtaining exactly 5 wireless only households based on a sample of 20 households? So for part A, what we're doing is we're going to be asking 20 families. We want X equals 5. What's the probability of having 5 families out of the 20? Exactly 5. Probability of a family being landline, no landline, wireless only is 0.25. 1 minus P or Q is 0.75. And so then we would either plug into that complicated formula or we go to StatCrunch. What we're going to do, we're going to follow these instructions right here. Stat calculator's binomial, and we have our values to plug in. And so the key thing here is identifying if it's a binomial probability experiment. Calculator's binomial. And then we go ahead and it was n equals 20. Probability of success was 0.25. And I want the probability that exactly 5 families out of 20 would be wireless. And so then we have this probability right here. And it turns out to be the probability is 0.202, about 20%. And so on this problem, what we're calculating is the probability that X equals 5. That exactly 5 families are wireless is 0.202. That's how easy it is. Let's try another one. B. What is the probability of obtaining fewer than 3 wireless households based on a random sample of 20? So we have the same information, and what we're trying to calculate here is the probability that we have fewer than 3, so that it is X is less than 3. We're trying to figure that we have fewer than 3 households, because that would also mean x is e. So in this case, for this problem here, what we're trying to calculate is what is that equal to when x is equal to 0, 1, or 2, right? And so we get the probability x less than 3. So we go back to StatCrunch. And in this case, I'm going to put a 3 in here. And I'm going to change this symbol to less than 3. Compute, and we get 0.091. And then that's the answer right there, 0.091. And so that's what would be put right here. Should have did it in a different color. Probability of having less than 3, fewer than 3 families is 0.091, I think it was. Double check. 0.091. You got it. Okay, let's go on to C. Looking at C here, probability. What is the probability of obtaining at least 3 wireless companies based on a sample random of 20 households? At least 3 means greater than or equal to 3. So that's, there we go. You need to recall important information. At least is greater than. It's the same language. At least, where was that note I showed you? Somewhere here. Right here. At least, no less than, greater than, or equal to. They're all those symbols there. And so we're calculating that probability. And so you go back to StatCrunch. We're not using the formula. StatCrunch is doing it. Turn that to greater than or equal to, and now we have 0.909 right here, 0.909. And so the answer is 0.909. About 90% chance that 3 or more households, or at least 3 households, will have, out of 20 will be wireless. And then let's finish this up with D. Here's D. What's the probability of obtaining between 5 and 7? So we're looking here, probability that x is between 5 and 7. X is between 5 and 7. Based out of that, and so we go back to the calculator. There's a between right there. 5 and 7. Get that there. Let's reread that question real quick. The probability between 5 and 7, well, inclusive, that's where we got inclusive. So we want, let me change that symbol here. Thanks for, if someone was thinking about, sorry about that. And so then our answer is 0.483. 0.483 would be the probability. There we go. And so this is how we calculate binomial probabilities using StatCrunch, which is really using this complicated formula based on a probability binomial experiment. That's the end of part 2.